Assalamualaikum and good day. This video is about the two-phase method. This method is an alternative to the Big M method. Means, if you have artificial variables in the model, therefore you can use either the Big M method or the two-phase method to find the solution of the problem. This method involves two phases, the phase 1 and phase 2. Step 1 in phase 1 is same as step 1 in the Big M method, where you need to transform the model to standard form and also to write the model in tableau form. Then move to step 2. Step 2 is to change the objective function to minimize the sum of the artificial variables. This is done by ignoring the original LP's objective function. The objective function in phase 1 is minimize R, where R equals to summation of AI. For example, if you have two artificial variables in the model, A1 and A2, then the objective function in phase 1 is minimize R equals to A1 plus A2. Then you need to eliminate artificial variables from row 0 in step 3. And then check the optimality of the tableau. Okay, means if the tableau is not optimal, then you need to find the entering variable, leaving variable, and update the tableau. Then in step 4, if you reach the optimal tableau in phase 1, you need to check the value of R. If R is less than or equals to 0, then you can proceed to phase 2, where the problem has feasible solution. But if the value of R is less than 0, then you need to stop solving the problem because the problem has no feasible solution. Okay, if R is greater than 0, the LP has no feasible solution. So you don't have to proceed to phase 2. In phase 2, you need to write the initial tableau. This is done by deleting all artificial columns in the optimal tableau from phase 1. And then replace the row 0 with the objective function of the original LP problem. After you write the initial tableau, then you need to make sure that all basic variables must have 0 coefficient in row 0. Means you need to eliminate all basic variables from row 0 before beginning the simplex. And then you can check the optimality of the tableau. If the problem is still not optimal, then find the entering variable, leaving variable, and then update the tableau. Continue the repeat step 3 until you find the optimal solution. Okay, let's discuss example 3.10. In this example, we use the same model as in example 3.9. In that example, we solve the problem by using the Big M method. If we want to solve the problem by using the two-phase method, we need to write the model in standard and tableau forms. Okay, this is the tableau form of the model. We have artificial variables in row 2 and row 3. Instead of using the Big M method, we can use two-phase method to solve the problem. Okay, to proceed with the two-phase method, we need to change the objective function to minimize R, where R is summation of A2 and A3. Minimize R equals to A2 and A3. Then, and transfer this term to the left-hand side. So, we have minimize R minus A2 minus A3 equals to 0. With this objective function and this constraints, then we need to write the initial tableau. Okay, this is the first phase, phase 1. Okay, basic variable row 0 is R. S1 is basic variable for row 1. A2 as basic variable in row 2. And A3 is basic variable in row 3. Coefficient of R is 1 in row 0 and 0 in other rows. X1 is 0 in row 0, same as X2, S1 and E2. We only have A2 and A3 in row 0. The coefficients for A2 is -1 and -1 is the coefficient for A3. The right hand side is 0. Then we write all the coefficients of these variables in every row. Okay, in the initial tableau, we can see that the coefficient of S1 is 0 in row 0, but A2 and A3 have -1 coefficients in row 0. We know that all or every basic variable must have 0 coefficient in row 0. We need to eliminate A2 and A3 from row 0. To eliminate A2 and A3 from row 0, we need to update row 0. Okay, the ERO for row 0 is row 0 new is equal to row 0. Okay, since we have A2 in row 2, so we need to include row 2 in the ERO. So plus R2, because this is positive and coefficient of A2 in row 0 is negative, so we need to multiply by +1 for row 2. And then we use row 3 because we want to eliminate A3 from row 0. So plus row 3. Okay, then we can update the tableau. So basic variable for row 0 still R, S1, A2 and A3 are basic variables in row 1, 2 and 3 respectively. R is 1, 0, 0, 0. Okay, for X1, okay, we get 0 plus 1 plus 1. So we have 2 here. 0 plus 3 plus 1. We get 4. S1, the coefficient is 0. E2 is -1. A2 is -1 plus 1 is 0. And A3 is also 0. The right hand side is 30. Okay, for other rows, we just rewrite the same coefficient as in the initial tableau. Okay, after we get a new row 0, now we can proceed to the next step, where we need to check the optimality of this updated initial tableau. Since we want to minimize R, we need to make sure there is no positive coefficient in row 0. Since x2 and x1 have positive coefficient, therefore this tableau is not the optimal tableau. Okay, we need to choose the variable with the most positive coefficient as the entering variable. Then, to select the leaving variable, we need to calculate the ratio. Okay, ratio for row 1 is 16. Ratio for row 2 is 20/3 or 6.67. And ratio for row 3 is 10. Since A2 has the smallest ratio, therefore A2 need to leave the basis. Now we can update the tableau. Okay, go to tableau 1. Okay, now x2 will replace A2. We have R, S1, X2 and A3. Coefficient of R always 1 in row 0 and 0 in other rows. Okay, first we need to update row 2. Since the coefficient of X2 in row 2 is 3, now we want to change the coefficient becomes 1. So the ERO for this row is row 2 divided by 3. So we get 1/3, 1, 0, negative 1/3, 1/3, 0 and 20/3. Okay, and we want to have 0 coefficient for x2 in other rows. Let's start with row 3. Okay, the ERO for row 3 is row 3 minus new row 2. Okay, so we will get 2/3, 0, 0, 1/3, negative 1/3 and 1, and the right hand side is 10/3. Now the ERO for row 1 is row 1 minus 1/4 row 2. For x1, we will get 1/2 minus 1/4 times 1/3. So it is 5/12. Okay, for x2, 1/4 minus 1/4 times 1 equals to 0. S1, 1 minus 1/4 times 0 is 1. For E2, 0 minus 1/4 times negative 1/3 equals to 1/12. For A2, 0 minus 1/4 times 1/3. It is equals to negative 1/12. For A3, 0 minus 1 over 4 times 0. It is 0. And right hand side is 4 minus 1 over 4 times 20 over 3. So it is equal to 7 over 3. Now for row 0. Since the coefficient of x2 in row 0 is 4, therefore the ERO is row 0 minus 4 times row 2. Okay, from this row 0, we get x1, the coefficient of x1 is 2 minus 4 times 1 over 3. We get 2 over 3. 4 minus 4 is 0. 0 minus 4 times 0 is 0. E2 is negative 1 minus 4 times negative 1 over 3. We get 1 over 3. For A2, it is equal to 0 minus 4 times 1 over 3. So negative 4 over 3. And A3 is 0. Right hand side is 30 minus 4 times 20 over 3. Is equal to 10 over 3. Okay, now let's check we already update the tableau. Now check the optimality of W1. Okay, remember the objective is to minimize R. Therefore, we need to make sure all coefficients in row 0 are non-positive. Since we still have positive coefficient in row 0, therefore, W1 is not the optimal tableau. Okay, back to step 3, where we need to select the entering variable. Okay, since x1 has the most positive coefficient in row 0, therefore, x1 is the entering variable. Then, find the leaving variable. Okay, calculate the ratio. Ratio for row 1 is 7 over 3 divided by 5 over 12. So we get 28 over 5. For row 2, the ratio is 20. And row 3, the ratio is 5. Okay. From here, we know that A3 need to leave the basis. In W2, the basic variable in row 0 is R. Basic variable in row 1 is S1. Row 2 is X2 and row 3 is X1. Coefficient of R is 1 and 0. Okay, now we update row 3. Okay, since X1 replaced A3 in row 3, therefore the coefficient of X1 in row 3 must become 1. Okay, to get 1, okay, we multiply the whole row 3 by 3 over 2. Okay, now we get 1, 0, 0, 1 over 2, negative 1 over 2, 3 over 2, and the right hand side is 5. Okay, now let's update row 0, 1 and 2. Okay, for row 2, the ERO is row 2 minus 1 over 3, row 3. The new row 3. Okay, using this ERO, we get coefficient for every variable in row 2 is 0, x2 is 1, S1 is 0, A2 is negative 1 over 2. A2 is 1 over 2. A3 is negative 1 over 2 and the right hand side is 5. Okay, let's move to row 1. To update row 1, the ERO is row 1 minus 5 over 12 new times new row 3. Okay, so the coefficient of x1 is 0, x2 also 0, s1 is 1, e2 is 1 over 2 minus 5 over 12 times 1 over 2. Therefore, we get negative 1 over 8. For A2, negative 1 over 12 minus 5 over 12 times negative 1 over 2. So we get 1 over 8. This time is positive. And for A3, the coefficient is 0 minus 5 over 12 times 3 over 2 equals to 5 over 8. And right hand side, we get 7 over 3 minus 5 over 12 times 5 is equal to 1 over 4. Okay, now the last row, row 0. The ERO is row 0 minus 2 over 3 times row 3 new. Okay, we get 0, 0, 0, and E2 is also 0. 1 over 3 minus 2 over 3 times 1 over 2. Alright, 0. And A2 is negative 1. A3 is negative 1. And right hand side is 0. Okay, now check whether tableau 2 is optimal tableau or not. Okay, now we see no more positive coefficient in row 0. Therefore, tableau 2 is the optimal tableau in phase 1. Okay, now check whether the problem has solution or no solution. Okay, check the value of R. Okay, since R is equals to 0, okay, R equals to 0, where for R less than or equals to 0, the problem has a feasible solution. Now we can proceed to phase 2. Okay, in phase 2, okay, we need to eliminate all columns of artificial variables. Okay, we just use the same coefficient in optimal tableau in phase 1, but we need to eliminate columns of artificial variables. Okay, we delete these columns. Okay, and we replace R with Z. Okay, now the BV in row 0 is Z, S1, X2, and X1 are BVs in rows 1, row 2, and row 3 respectively. The coefficient of Z is 1 in row 0 and 0 in other rows. Okay, now let's we just fill in the coefficient of every variables in row 1, 2, and 3. Okay, x1 is 0, 0, 1. x2 is 0, 1, 0. s1 is 1, 0, 0. and E2 is negative 1 over 8, negative 1 over 2, and 1 over 2. The right hand side for every rows, okay, are 1 over 4, 5, and 5. Okay, now for row 0, we need to fill in the coefficient of the original objective function. Okay, the original of objective function is minimize z minus 2x1 minus 3x2 equals to 0. Now we just fill in this coefficient into the row 0. So negative 2, negative 3, 0, 0, and 0. Okay, now since x2 and x1 are basic variables, they cannot exist in the objective function. Therefore, we need to eliminate these variables from row 0. Means we need to update the initial tableau of phase 2. To eliminate x1 and x2 from row 0, we need to use this ERO. Okay. New row 0 is equal to row 0. Okay, the coefficient of x1 is negative 2 and the coefficient of x1 in row 3 is 1. Therefore, we need to plus 2 times row 3. And to get 0 coefficient for x2 in row 0, we need to plus 3 times row 2. Okay, this is the ERO to get the new row 0. Okay, from here, from this ERO, we get 0 for x1 and 0 for x2. x1 is also 0 plus 2 times 0 plus 2 times 0 is 0, and E2 is 0 plus 2 times 1 over negative 1 over 2 and plus 3 times 1 over 2. So we get negative 1 over 2, and the right hand side is 0 plus 2 times 5 is 10 plus 15. So we get 25. Okay, now let's check the optimality of this updated initial tableau in phase 2. Since the objective is to minimize z, we need to make sure that all coefficients in row 0 are non-positive. Since all coefficients in row 0 are non-positive, therefore, this initial tableau is the optimal tableau. Okay, the optimal solution for this problem is x1 equals to 5, x2 also equals to 5, s1 equals to 1 over 4, e2 equals to 0, and the optimal value is z equals to 25. Okay, that's all about the two-phase method. Thank you.